Welcome back, guys. So today we are going to learn how to quickly solve multi-step equations without parentheses. So as I've said in previous videos, what you want to do whenever you're solving a linear equation, you want to separate the variables from the constants. So you want to separate the variable terms from the constant terms, which are the numbers by themselves. So if you look carefully here, you have a 2x plus 13 on one side, and then you have 5x minus 2 on the other side of the equal sign. Our goal is to separate them. Now, you could technically move the numbers on this side and the variable terms on this side, or vice versa. It doesn't matter. However, there is usually going to be one side that's a little easier to use, and let me show you what I mean. So if we look carefully here, you've got the 2x plus 13 on this side, and the 2x is smaller than the 5x, and 13 is larger than the 2. So whenever that's the case, usually it is easier to move the smaller term to where the bigger term is. So the 2x makes more sense to move it over to where the 5x is, and the 2 move it over to where the 13 is. Okay, so let's go ahead and do that. For variable terms, I'm going to use the red color, and for the constant terms, I'm going to use the green color so we can keep track. So I want to move over the 2x to where the 5x is. To do that, I always do the opposite value underneath it. Okay, so since 2x is a positive term, I'm going to write negative 2x underneath it. What this will do is it will eliminate the 2x on this side, but to keep the equation balanced, I have to do the same thing to the other side of the equal sign. So I have to cross the equal sign here, and I have to do the same amount. We're balancing the equation. Whatever you do to one side, you do to the other side. Okay, so then I'm going to create a long line here. Now underneath this line, I'm going to write the result. And the result will be either a subtraction or elimination. But to solve this quickly, what I'm going to do is I'm going to do two steps in one. Here's what I mean. So this step will eliminate the x term, the 2x, and merge it with the 5x on the other side. But I'm also going to eliminate the 2 from this side, since this has a subtraction that acts as a negative value for the 2. So underneath it, I'm going to put a positive 2 or a plus 2. And whatever I do to this side, I have to do to this side. So if you look carefully here, to eliminate the 2x, I subtracted it because it was positive. To eliminate the 2 here, I added it because it has subtraction. All right, now what happens? Underneath this line, I'm going to write the results. Well, if you look carefully, the 2x minus 2x, they're the exact same value subtracting. They cancel each other out. On this side, 5x minus 2x will give us 3x. The coefficients, the numbers in the front, subtract. 5 minus 2 gives you 3. X comes down. And then we do the constants, the numbers. The minus 2 and the plus 2, they're opposites. So that's the same as saying 2 take away 2. So they will eliminate each other. And on this side, they will add because they're both positives and they have plus signs in front. So this will add to 15 underneath it. Now I'm also going to bring down the equal sign because this is still an equation. So voila, in one swoop, I did two separate steps. I merged the constants together, and I also merged the variable terms together. My final step is to isolate the variable x, aka leave the x alone. To do that, I have to remove the 3 in front of the x, the coefficient. Now, if you recall from my previous videos, in order to eliminate coefficients, you gotta divide them because they are multiplying the variable. So 3x is the same as saying 3 times x. So to divide, what I do is I use a fraction bar and I bring down the 3. 3 divided by 3 will eliminate into a whole here. And whatever I do to one side, I do to the other side. 15 divided by 3 will give me 5 equal, and then the 3's here cancel into a whole, so leaving me with 1 x or simply just x. Therefore, that's my final answer. 5 is equal to x. And we just solved for x. Let's take a look at another example. All right, this is a similar equation, different terms here. So take a look at it. If you want, you can pause the video and give it a try on your own. Think about which terms you want to move where. Okay. All right, let's give it a try. Okay, so if you look carefully here, you've got 8a on this side and 6a on this side. All right. Which term do you think it's going to be easier to move? 8a to where the 6a is, or 6a to where the 8a is? Well, the rule of thumb is the smaller term is usually easier to move over to where the larger term is, especially if the larger term is a positive term. So the 8a is positive here because it doesn't have a negative in front. Okay, long story short, I am going to subtract 6a on this side because it has a positive sign or a plus in front of it. So I'm going to put a negative underneath it. And I'm going to do the same thing to the other side. Because remember, whatever you do to one side, you do to the other side. And I make sure that the like terms go underneath each other. So this one is also going to have a minus because I need to do the same value to both sides. Okay. But I still have to deal with the constant terms, the 15 and the 3. Now, normally I'd say you want to move the smaller term to where the bigger term is. However, in this case, I moved the 6a to where the 8a is. So by default, I have to move the 15 to where the 3 is. So in order to move 15, I have to do the opposite operation of 15. So in this case, because it has a subtraction, I got to do addition underneath it. And whatever I do to one side, I have to do to the other side. So plus 15 on this side as well. Now let's go ahead and do the calculations here. Well, the 6a minus 6a cancels. And the 8a minus 6a will give me 2a on this side. The 15s will cancel because one has subtraction, one has an addition. They are the same value but opposite signs, so they cancel into a 0. And the 3 plus 15 gives me 18. All right. Now I'm going to bring down the equal sign here. And I'm almost there. Now the 2a, I should rephrase myself. The a is not alone. I have to remove the 2 in order for the variable to be totally isolated. So just like I did in the previous slide, I need to remove the coefficient. So to remove a coefficient, we got to divide by exactly that coefficient. So I got to divide by 2. Whatever I do to one side, I have to do to the other side. So here's my final answer. A is equal to 18 divided by 2 will give me 9. And that's my final answer. The variable a is equal to 9. All right. Let's do one more slide. Okay, similar equation. Let's think about this. Which term do you want to move where? Now remember, you want to move the variable terms on one side and the constant terms, aka the numbers, on the other side. So if we look carefully here, which C term makes sense to move over? You want to move over the 3C or the 5C? Well, 5C is greater than 3C and it's also positive. So in this case, it makes a little bit more sense to move over the 3C to where the 5C is. So I'm going to go ahead and write 3C underneath the 3C. And now we got to ask ourselves, do I add 3C underneath or do I subtract it? Well, the answer is quite easy because the original has subtraction, so I have to use addition. You always want to use the opposite operation or opposite value. If you see an operation like a subtraction or addition, you got to use the opposite. If there is no operation in front, aka no sign in front, then by default that would be a positive. So underneath the 35 you would put a negative if you wanted to cancel the 35. Okay, so I have plus 3C here. The other 3C has to go under the 5C because remember, we're eliminating terms on one side, but then we're merging it with a like term on the other side. In this case, the 5c. Since I did addition, I got to do addition here, because whatever you do to one side, you have to do to the other side. Now in this case, they're very close to each other, so it's a little tricky. Okay, let's do this long line. Now this line represents two things. This represents mainly the next step, or the step that comes underneath it. Okay, and in a certain way, I kind of think of it as the result, or the not exactly the equal value, but the total of each term underneath. Okay, so now we got to ask, am I supposed to move the 35 now or the 21? Now normally you can move either, but in this case, because we moved over the 3c to where the 5c is, the c terms cancel on this side. Therefore it makes sense to move over the 21 where the 35 is, since the 35 is going to be all alone. So here I'm going to add 21. Whatever I do to this side, I'm going to go ahead and do to this side. I'm adding 21. Alright, let's go ahead and write the answers. So this will be 56. The 3c and the 3c will cancel here because one has subtraction, one has addition. I'm going to bring down the equal sign here. Now the 5c plus 3c will give me 8c. And the 21s over here will cancel because they have opposite signs. One has subtraction, one has addition. All right, final step. What is c when left alone? Well, to figure that out, I gotta divide. So I'm going to divide both sides by the coefficient, which is 8. Therefore, c is equal to, let's divide by 8. 56 divided by 8 will give me 7. So the value of c in this case is equal to 7. Now, you might say, well, how do we know that this is actually correct? Well, to check that you are correct in your final answer, you could do what's called a check. So let's do it really quickly on this side. How do we do a check? Well, first you copy the original equation. So here would be the 35 minus 3c equal to 5c minus 21. Now underneath it, because we're checking, we're gonna see, or we wanna figure out if the answer for c is actually 7. So instead of using c, we're gonna put in 7. So we're gonna substitute the variable c with the number 7. So underneath it of the original equation, I'm gonna change the c's only. So the 35 stays as 35 because it doesn't have a variable, minus 3. Now when students start working with variables in the beginning, they simply put in the number where the variable is, like this, and they just leave it like that. This is not quite accurate because the number does not become 37. That is actually 3 times 7. 3c is 3 times c, so this is 3 times 7. So to represent multiplication, whenever you substitute, you could technically use a dot, but most mathematicians use parentheses. So whenever you substitute a new value into an equation, you use parentheses. And that's multiplication, 3 times 7 equals, now here we have 5c, so that becomes 5 times 7 again, minus 21. Again, the parentheses represent multiplication. The only reason why we don't use the x or the dot symbol is because we are substituting it into the equation. It's a substituted number. Okay, so let's go ahead and do the next step. Well, the next step would be to multiply the 3 with the 7 and the 5 with the 7. So this will be 21. This will be 35. You probably have noticed the answers I write below. I don't write them on the side because that would be incorrect, because that would change the equation. So the answers go underneath. I bring down the equal sign, and then in this case it has a subtraction, so I bring down the subtraction and the 35 in front, and here would be minus 21 in the back. Now if you look both sides of this equation, they are identical, so you know that these two sides are actually correct because they are equal to each other. There's no doubt. All right, well, what is 35 minus 21? Well, the answer would be 14. So the final answer, if we want to simplify all the way to just a single number on each side, that comes out to be 14 equal to 14. And that's our check. So the check is correct if both sides are actually equal to each other, and we can clearly see that they are. And with that, I'm gonna go ahead and end here. If you enjoyed this video, please make sure to like, comment on any questions you might have or any feedback that you want to give, and make sure to also subscribe. Thank you so much, and I'll see you in the next video.